Well, hello again, Algebra 2 students. In this particular set of videos, we're going to be looking at samples. So as we work with statistics and the gathering of statistics, sometimes we're going to be taking a sample. When it doesn't make sense to, let's say, poll the entire population of America on whether or not they support the current president or one of the particular candidates in the race right now, you would take a sample. You would call a certain number of those people, and the more people that you would talk to and the more people that are part of your sample, the more accurate your data and statistics are going to be. So that's the idea that we're looking at in these slides. So when conducting a survey, you need to make the size of your sample large enough so that it accurately represents the population. As the sample size increases, the margin of error is going to decrease. It should pop up, margin of error. There we go. The margin of error gives a limit on how much the responses of the sample would differ from the responses of the entire population. So if we were to talk to all 300 million people in America, we'd be within a certain range or a certain margin of error from the number we get from our sample. Here's the formula for finding the margin of error. If a random sample size of n is taken, the margin of error is approximated by taking 1 divided by the square root of n. Plus or minus means that we could be a little bit over the actual number or a little bit under the actual number. This means that if the percent of the sample responding a certain way is expressed as decimal, then the percent of the population that would respond the same way is likely to be between p minus 1 over the square root of n and p plus 1 over the square root of n. So that'd be, the actual number, a little bit lower and a little bit above. Okay. Now to make this work, let's say in a survey of 439 teenagers in the U.S., 14% said that they worked during their summer vacation. What's the margin of error for the survey? Well, in order to do that, we need to take n, which is the number of people in the sample. We're going to take the square root of that. In this case, it's going to be the square root of 439. And we are going to take 1 divided by that number. Our margin of error is going to be plus or minus whatever that happens to be. So plugging that into a calculator, if we take 1 divided by the square root of 439, we get 0.0477. So I'm going to go ahead and round that and say that that's 4.8%, if you don't mind. So coming back here, this is about plus or minus 4.8%. And again, we change decimals to percents. I like to have a percent when we do these kinds of problems. So that's my margin of error, 4.8%. If I'm asked to give an interval that's likely to contain the exact percent of all U.S. teenagers who worked during the summer vacation, well, if my margin of error is 4.8% and 14 was the number that I had initially, to find this interval, what I'd be doing is I'd be thinking about, okay, well, what would be 4.8 greater than 14 and what would be 4.8 less than 14? Well, if you do a little bit of math, you'll end up with the numbers 9.2% would be on the low end. So we're going to have at least 9.2% of teenagers working during the summer vacation, all the way up to, if I add, that's going to be 18.8%. So we can pretty confidently say that if we were to poll all of the teenagers in the United States, the number that worked during their summer vacation would be somewhere between 9.2 and 18.8%. Again, you may think that that's not real numbers. We're just picking a number and going with it. It's not. It's just an actual poll that I did. Okay. Anyways, there would be my interval. I use my margin of error to find an interval in which the actual number would most likely be. Now, if we keep rolling with this idea, next problem. A polling company conducts a poll for the president's approval rating. How many people did the company survey if the margin of error is plus or minus 5%? Well, here we know something a little bit different. Instead of knowing n, the number of people in the survey, we know what the margin of error is. So as I think about my equation, I knew that my equation was 1 over the square root of n was equal to that margin of error. So my margin of error is 5%. I'll put that right over here as 0.05. Okay. Now the plus or minus would be in my answer and my equation. I don't really need to worry about that as I solve this equation for n, the number of people that were in the survey. Now as I solve, we're going to multiply both sides by the square root of n because I don't want to have it in the denominator. So I'll put that over here. And then what happens is we divide by that 0.05. Now you'll notice as we do this, essentially what happens is the 0.05 and the square root of n are just going to switch places. Okay, divide by 0.05. And what we'll have is something that looks like this. The square root of n is equal to 1 over 0.05. Now as we solve, I need to solve a radical equation. Well, to get rid of that square root, we square this side, which will leave me with n. And then I square the other side as well. So 1 over 0.05 is going to be squared. Be careful with your parentheses here. We could type that into our calculator though. If we have parentheses, 1 divided by 0.05, close parentheses, and square that expression, we end up with 400. So 400 would be n, the number of people that were in this particular survey. So that's solving an equation where you know the margin of error but not the number of people. Next problem. Gallup Youth Survey reported that 23% of students surveyed, or about 181 students, say that math is their favorite subject. Awesome. How many students were surveyed? Now, this was a little bit different. This is not actually the results of the survey. This just tells us, 23% of the students surveyed, or about 181 students. So this is a little trickier. We want to find the number of students that were surveyed. Well, 23% of the number that's surveyed is 181. So what I'm trying to figure out now is I'm going to use what I like to think of as the percent equation. 23%. So 23% of meaning multiply. What number is 181? When I think about, well, how do I solve this equation? 23% of some number is 181. To solve for that number, I can put an X there, a box there, whatever. I just happen to put a question mark. I'm going to divide by 23% to solve for that particular number. Now, when I do that, again, we don't use percents in equations. We change things to decimals. So what's going to happen is I'm in my calculator going to type in 181 divided by 0.23 because that's the same as 23%. When I do that, I get this 786.95. All right, well, we'll round that up. That's pretty close to 787, so we'll go with that. So how many students were surveyed? 787 of them. Okay, now that we know how many were surveyed, when we're asked to find what's the margin of error, well, I'll find the margin of error. I take 1 over the square root of the number that were surveyed. So 1 divided by the square root of 787. 1 divided by the square root of 787. Oops, don't need that. Hit enter. 0.0356. I'll round that and say 3.6%. All right. So plus or minus, always 3.6%. All right. And then to give an interval that is likely to contain the exact percent of all students who would say that math is their favorite subject, well, if 23% was the amount that we got from the survey, again, we're going to look at 23 and we're going to be 3.6 above it and 3.6 below it. So when I do that math, I've got 19.4% on the low end up to 26.6 on the high end. So there would be my interval that I could be pretty confident in saying that here would be the percent of all students that say that math is their favorite subject, my favorite kind of kids. So that should do it for working with margin of error and sample intervals. Good luck.